laser scanners, which I've worked with this quite a bit as well. We have the LiDAR instrument and the object of desire. The LiDAR instrument emits a signal, it reflects off of that surface. Two things are measured, the time of arrival of that signal as well as the angle of arrival. The locus of points of space having the same distance from a fixed point would give us a sphere. The locus of points of space having the same angle from a fixed point would give us a line. The intersection of these two would give us a probable location of that reflective surface relative to the location of the scanner. So we have the 3D coordinates exactly relative to the location. And then that ray changes incrementally vertically and then horizontally. Essentially, we would have a full panoramic image of that, which are referred to as point clouds. Now, these technologies exist. We are able to acquire these point clouds from construction projects. What is hindering its ability to be utilized in mass right now in construction projects? There's one very major reason, and that is we have a lot of data that needs to be processed, and is processed typically through manual intervention. Now let's see what the problem with the manual intervention is, if we want to extract information, semantic information, from these point clouds manually. So, one of the problems is with respect to the amount of data and the amount of information that we need to extract. For instance, this is a construction site. Each and every one of these elements are hollow structural members. Each and every one of these elements needs to be extracted. So we need some sort of software to open it up, some manual person to actually go through it and say which one of these points belongs to which one of these elements. Yes? So this is tedious if we want to do it every day or in a high frequency. Yes? So it's not practical. Another problem with this is that it's actually subjective, other than the fact that it's time consuming. It's prone to errors as well, and I'll show you in this example. We have the point cloud of a rectangular reinforced concrete column. I've given this from the top view to 6 different colleagues of mine and asked them to say which one of these points they think belongs to the top right rebar. Each and every one of them actually came up with a different set of points that they felt looked the most like it would represent that rebar on the top. Because of that, when you fit the best fit curve on that, it's going to give us different models. We want to make sure, and that all of these models are, of course, different from the parametric model, which is the best fits that we can get automatically. So we want to make sure that this subjectivity is also minimized, meaning the person that is actually responsible of extracting that would extract that as accurately as possible. So this is where we developed the system to be able to automatically extract semantic information that we require.